Okay, so question number 7. Why is why is an HCl molecule polar but a Cl2 molecule is nonpolar? So HCl, let's draw its Lewis structure. Hydrogen has 1 electron, fluorine has 7. So its Lewis structure would just simply be single bonded hydrogen to the chlorine. And I can show all the lone pairs on chlorine as well. And the reason why this molecule is polar is because chlorine is so much more electronegative than the hydrogen that we have a non-zero dipole moment pointing towards the direction of chlorine. So now we can show that the hydrogens are partially positive, the chlorine's partially negative. So therefore this molecule is polar. But if we were to compare it with Cl2, we just have a diatomic chlorine, and then we can show the lone pairs. And every time you have a diatomic molecule, this means that it's also nonpolar. And the reason why is because these chlorine atoms have the exact same electronegativity, so they're going to cancel each other out. So we can say that we have no dipole moment, because they cancel each other out. So therefore Cl2 is nonpolar. Okay, so the junior tutor said that a polar covalent bond is created when the shared electrons between atoms are not equally shared. This occurs when one atom has a higher electronegativity than the atom it is sharing with. As a result, the shared electrons will be closer to the atom with the higher electronegativity, making it unequally shared. Bond polarity is the separation of electric charge along a bond. However, the electronegativity difference between chlorine atoms is 0. Therefore, the shared pair of electrons is attached equally to both chlorine atoms and remains exactly in the center, making chlorine-chlorine bond nonpolar. Since the chlorine atom is more electronegative than the hydrogen, the shared pair of electrons is attracted to the chlorine atom. This results in the chlorine atom acquiring a negative charge while the hydrogen atom acquires positive charge. Distribution of electrons across the molecule becomes uneven, making the molecule polar. I'm just going to add that they're partially negative and partially positive. Okay, but the solution is correct.